Hello everyone, and welcome to Modeling and Optimization in Calculus. This is the first of a three-part video series that will go through all the modeling and optimization questions. And we're going to start with number 1. An open top box is to be made by cutting congruent squares of length S from the corners of a 20 by 25 inch sheet of tin and bending up the sides. So here's my sheet of tin. And I'm going to make little cuts. They're going to be side length X, and they're little squares. And let's actually cut them. So I cut them like that. And then I'm going to fold up the sides. So I'm going to use a little dashed line to indicate where I folded up. Can you picture this? This is a very shallow box that I'm going to have at the end of this. I'm not great at drawing 3D, but hopefully you can picture it look something like that. So when I fold it up, its height is going to be X. And when I cut out those corners, remember the sheet of tin used to be 25, but I've cut an X out of both corners. So this new distance is 25 minus 2X. So I'll put it in red for you. This distance right here is 25 minus 2X. And then going along the other direction, that used to be 20. I wrote 25, but that used to be 20, and now it's just going to be 20 minus the 2 x's that you cut out. So when you fold this little section up here, it's lost those 2 x's. Now I just drew it one way. There's so many ways I could have drawn it. Again, starting with my 20 by 25 inch sheet of tin, I could have cut out much larger x's, and that would have given me a different shaped box. The question is, does it have a different volume? Absolutely. So depending on how much you cut out, this is all going to change. So your volume is going to be length times width times height. But I'm going to rewrite it as length 25 minus 2x times width, which is 20 minus 2x, times the height, which after you fold these little corners up is going to be x. If you multiply this out, you will get a cubic x times x times x, a cubic equation. So let's do that real fast here. We get 500 minus 50x minus 40x plus 4x squared times x. You can only multiply two things at a time, but I can do several things here. I'm going to put it in descending order as I multiply, and I'm going to add those together. So minus 90x times x would be x squared plus 500. So it's some kind of a cubic equation, and it is going up. So I don't really know, maybe something like that. Okay. But at some point, it's going to have the best possible volume. Actually, that x makes all the difference because now I know its intercept. So I can graph it just a little bit more accurately. So what's going to happen is the volume is going to change based on how much you cut out. So if you don't cut out anything, then you can't make the box, so the volume is 0. And if you cut out just a little teeny tiny bit, you're going to get a really, really flat box with a very small volume. And that volume is going to keep improving until you have some kind of awesome volume. But then eventually you will have started to cut too much of your box, and it's going to become incredibly tall and skinny. And that also will be a problem. So its volume will start to decrease. Now, what do these numbers represent? Those numbers represent the fact that there is a domain. There's only so much that you can cut out of it. So once you reach 10, you have no more box because the length of this side is only 20. So the most that you're going to cut out. is going to be 10. You can write equal to, but then the volume will be 0 if you actually cut out 0 or cut out 10. So we can only look at this until 10, and then this part of the graph isn't going to matter to us. But what part of the graph does matter to us? We want to maximize the volume. We want this point right there. And now that we're in calculus, what's special about that point? We can find it using the derivative. It's where the derivative is equal to 0. So I'm going to take the derivative, which is 12x squared minus 180x plus 500. And how do I actually find that now? I set it equal to 0. That's what's special about that point. And I don't know, can I factor something out of here? 4 would give me 3x squared minus, is that 45? And then plus 125. So I don't look at that and immediately think that I can factor it. So I'm going to do the quadratic formula. I only need to do it on this part because I'm trying to figure out where this section is equal to 0. So I have negative b plus or minus the square root of b squared minus 4ac all over 2 times a. Now, I don't know if you have used the easiest way to do this on your calculator, but I'm going to take a quick break from this and show it to you on your calculator. To do the quadratic formula on your calculator, start with this green button and then the y1, which will give you f1, which is how you make a fraction, so hit enter. And then you can literally not have to simplify anything yourself. You do have to choose between plus or minus. We'll get to that in a minute. So second square root 45 squared. Notice I'm not trying to simplify in the middle of this problem at all. I'm literally just typing it in like I see it. Even this part, you can write 6 if you want to, but 2 times 3. And then hit enter. And you get 11.318. And now I hit second enter, and that repeats the equation so that I can go back and change that plus to a minus. Change that to a minus, hit enter again, and these are my 2 answers. Now, of these 2 answers, remember that 11.318 is outside of our domain. We can't cut more than 10 out of this box. So the actual answer is going to be 3.681. So I got 3.681 inches. I do always have to go back and read the question and see what they were looking for. So it says, find how large the cutout square should be so that the box can hold as much as possible. So you should cut out 3.681 inch by 3.681 inch squares. And then it says, find the resulting maximum volume. So you would take 3.681 and you would plug it back into this equation. Now remember, this number is actually already on your calculator. So the quickest way to do this would be to store as x without even rounding it. Don't do 3.681, just while it's still on your calculator. Hit the store button as x, and then on the next line type in this equation. Don't type in your simplified one in case you made a mistake. Type in 25 minus 2x times 20 minus 2x times x. And the volume will be 820.5 to 8 cubic inches. And that's number 1. Now, what I'd like to do is go back and put steps next to all of these, because the steps for modeling and optimization, they won't change much from problem to problem. So step 1 is going to be right here. And you can line it up if you didn't use this space already. So for step 1, write the equation you're trying to optimize. So all of these are going to be a max or a min problem. And you can go straight to the end. Find the resulting maximum volume. You're trying to maximize the volume. You should be writing a volume equation. Step 2, write equations for the constraint. There might be more than one. So in this case, these are the things that were constraining us. The length is equal to 25 minus 2x. That's step 2. The width is 20 minus 2x. And the height is x. These are our constraints. We can't just make the box as big as we want because we're being constrained by this piece of tin. Step 3, which is going to be right here. Use the constraints to rewrite equation 1 using only one variable. So notice we had a length and a width and a height, but now we have an equation with just x's in it. So I used my constraints to make an equation that only had one variable. Step 4. We did simplify. I'm not going to write that as a step. Step 4 is right here. You're going to take the derivative. Step 5 is you're going to set the derivative equal to 0 and solve. And step 6, as funny as it sounds, answer the question. Sometimes people stop down here. This is not step 6. You have to go back and see what they wanted. They wanted to know how large should the cutout squares be and what is the resulting maximum volume. So make sure you actually look back and answer the question. They might want to know volume. They might want to know the length of the side. And step 7, add your units. So step 7 is right there. So these 7 steps, you're pretty much going to be able to use every time during this, which is why, as maybe intimidating as it might seem, a whole bunch of word problems, people actually like them because they like their steps. So let's do number 2. Find the largest possible value of 2x plus y if x and y are the lengths of the sides of a right triangle whose hypotenuse is square root of 5 units long. So x and y are the lengths of the sides of a triangle whose hypotenuse is square root of 5 units long. Okay, so step 1 is thing that you're trying to optimize. Well, in this case, they told you they want you to optimize 2x plus y. So I'm just going to call it m. Last time we called it v because we were doing a volume. This time I'm going to call it m because they didn't tell me what it is. I'm just trying to maximize, so I'm going to use m for maximize. Step 2, you need a constraint. So they're being constrained by this triangle. And in that triangle, it's a right triangle. So x squared plus y squared is equal to the square root of 5 squared, which is 5. Step 3, use the constraint to reduce our equation to one variable. So you can pick either x or y, it doesn't really matter. So x squared is equal to 5 minus y squared. X is equal to the square root. Now normally I would want you to put plus or minus, but x is the length of the side, so it's definitely going to be positive. And now I'm going to make my m equation, that's always the goal, to go back to your original equation and rewrite it so that it only has one variable. Step 4, take the derivative. Make sure you label it. So this one, I'm actually going to rewrite this first as 2 times 5 minus y squared to the 1/2 plus y. So I bring down the 2, that the 1/2 gets rid of the 2, and I get 5 minus y squared to the negative 1/2 times negative 2y, don't forget the derivative of the inside, plus 1. Now, on the outside chance you're thinking, ooh, we're doing y, we should use implicit differentiation. That's for when there's two variables in the equation. I'm actually doing the derivative of m with respect to y. Y is the variable that I'm changing around. So there's only one variable in my equation. I don't need a y prime. I am doing the derivative of m with respect to y. Step 5, let the derivative be equal to 0. So this is my derivative. I'm going to rewrite it a little bit. Negative 2y over the square root of 5 minus y squared plus 1. Now, this is pretty challenging to solve. My first instinct would be to put the 2y over here. And then I personally would clear the fraction. Anybody that's had me for any length of time knows that I'm a big believer in clearing the fractions. So that gives me 2y is equal to the square root of 5 minus y squared. I would square both sides to get rid of my root. That would give me 4y squared is equal to 5 minus y squared. Normally, I would set it equal to 0 and factor because I see a y squared. But because there's no y term, I can just isolate the y squared and then take the square root of both sides. But it's a length, so it's only going to be positive 1 as your answer. So in step 6, you're looking to find the answer. What did they want anyway? Find the largest possible value of 2x plus y. So if you just write x is equal to and y is equal to, you'll be wrong. So y is equal to 1. Therefore, this little symbol means therefore, a little triangle of dots. Going back to here, x is equal to the square, oops, that came out terrible. X is equal to the square root of 5 minus 1 squared. So 5 minus 1 is 4, squared of 4 is 2. So x is equal to 2. But that's not the answer. They want to know what 2x plus y will be. So 2x plus y is 5. And it's just units, so I don't need units. What is the largest possible value of 2x plus y? That's number 2. And now you can do number 2 on your homework. That's what this little bracket means. On the last one, now you can do 1 and 7 on the homework packet. All right, number 3. Find two positive numbers. So x is going to be equal to the first number. Y is going to be equal to the second number, whose sum is 36. So x plus y is equal to 36, and whose product is as large as possible. Okay, I found it. Step 1. What are we trying to maximize? We're trying to maximize the product of x and y. So x times y. Always ask yourself, what is it that they want me to maximize or minimize? Step 2, you're looking for the constraint. So if I want to maximize x and y, let's just make x a million and y a million. But I'm constrained by the fact that the two numbers have to add up to 36. So that's my constraint. Step 3, use the constraint to rewrite the main equation with only one variable. So let's do y is equal to, since I did x last time, 36 minus x So m is going to be x times, and I can replace y with 36 minus x. Step 4, take the derivative, which I am going to do, but I am going to simplify this first to 36. I don't want to use product rule on such an easy problem. 36 minus 2x. Step 5, set the derivative equal to 0. Nice easy derivative, nice easy solving. 2x is equal to 36. X is equal to 18. And then therefore, y is 36 minus x. So y is equal to 36 minus 18. Y is also equal to 18. So our question asks us to find two positive numbers whose sum is 36. So 18 and 18 make 36, and whose product is as large as possible. So 18 and 18 are the two answers. Are there other numbers? Sure. 1 and 35. 2 and 34. 3 and 33. All of these have a sum, and more, have a sum of 36. But the product is only 35. The product is only 68. The product of 18 and 18 is 324. So that's the best product. And how did we get that? By making a constraint and figuring out the equation we wanted to maximize or minimize. Would this work? Could you just go all the way down the chart? Absolutely. But number one, you'd only get a point for it because the rest of the points come from showing correct calculus. But it's just good to understand how this works. This is a negative parabola with zeros here and at 36, right? So you can use 1 and 35, but it's just not going to be as good an answer as you'll get from 18 and 18. So if you pick 1, your area is only going to be this big. If you pick 2, your area is only, but if you pick 18, your area is going to be, not area, your product is going to be that big. All right, let's do another one. Number 4. A city recreation department plans to build a rectangular playground. So x times y. Having an area of, so the area has to be 3,600 square meters. And they're going to surround it by a fence. Find the dimensions of the rectangle that uses the least amount of fencing. So there's a lot of combinations that could give you 3,600. You could make the playground super small and skinny, or you could make it really tall and skinny, or somewhere in the middle. And there's lots of XY factors that would make 3,600. But you've got to buy fencing, and you want to use the minimum amount of fencing. So fortunately, we know that derivatives find, when you set it equal to 0, find both the max and the minimum. So we're going to get both answers, and then it's just our job to figure out which one is actually the minimum, since we're trying to use the least amount of fencing, not the most amount of fencing. So this is the last one. I'm going to put steps on it for you. Step 1. What is the equation that you're trying to maximize or minimize? The fencing. So you can use F for fencing, or I'm going to use P for perimeter. Despite the fact that we are in calculus, number one biggest mistake is that P is equal to x plus y. No. Perimeter is both the lengths and both the widths. So 2x plus 2y. Watch out for that. Step 2, what are your constraints? So you're being constrained by the fact that they want the area to be 3,600. So x times y is going to be 3,600. Step 3, use the constraints to reduce the original equation to only one variable. It doesn't really matter which one you pick. Y is equal to 3600 over x because they're identical. So 2x plus 2 times 3600 over x, which gives me 2x plus 7200 x to the negative 1. Step 4. So I don't even know what this equation looks like. Certainly it's not a regular polynomial function, but somewhere it has a low point, and I want to find that. And when that happens, its derivative is going to be 0. So I take the derivative, 2 minus 7200 x to the negative 2, and I set that derivative equal to 0. Because whatever this graph looks like, I know that when the derivative is 0, that must mean I'm at a low point or a high point. So you can clear the fraction first or move it over first. It doesn't really matter. I did it by moving over first last time, so this time I'm going to excuse me, clear first. So 0 is equal to 2x squared minus 7200, and now I'll move over. It's the same either way. I divide by 2, and I get plus or minus 60. But of course, it can't be negative. It's the length of a playground. So x would be positive 60, and therefore y, which is 3600 divided by x, is also 60. And again, step 6, answer the question. Find the dimensions that uses the least amount of fencing. So the playground should be 60 by 60. Step 7 is kind of simultaneously 60 meters by 60 meters. Okay, so step 7 is units. Getting those steps down? All right, so we had a couple easy ones there. You can now do 4, 8, 11, and 16 on the homework. Which if you're in honors, I'll assign very specific homework. You are not going to have to do all of those problems. All right, let's do one more because I don't want you to think they're all getting easy. Next one's a little hard. Find the radius and height of a right circular cylinder. So right circular cylinder just means that it's not leaning. It lets you know that this is definitely upright. So do they make things like this? Absolutely. There's pipes and things that are at an angle. But ours is a right circular cylinder that minimizes, I found equation 1, minimizes the total surface area. So if you're in honors, make sure that as we introduce formulas that you're not familiar with, that you make a list of all the formulas for volumes and surface areas of all these different shapes. If you're in AP, yay you get to memorize all of these. AP does not give you any formulas. You're expected to know them. So I want to know the radius and the height of this right circular cylinder that minimizes the total surface area. So I'm actually not going to use M for minimize since it is a surface area. I'm going to use S for surface? Nah, A for area, even though we know it's surface area. And its volume is going to be the constraint. So let's make these two formulas real quick. If you understand how they're made, it'll help you memorize them. So the volume is a disk on the bottom, and that disk is just like any circle. Its area is pi r squared. So the volume comes from stacking those disks all the way up for a height of h. So the volume of a right circular cylinder is pi r squared h. So for R, I know I didn't do step 1 yet, but for step 2, the volume is going to be 36 pi is equal to pi r squared h. So they gave you the volume. It's a constraint. You have to have it fill that volume. And this is the formula for volume for a right circular cylinder. For the area of a right circular cylinder, there's two parts to it. It's a little tricky. You have a top, which is pi r squared, a bottom, which is pi r squared. So you have two pi r squareds. But then you have what we call the lateral surface area, which means like this side all the way around. So it's a ring though. It's not a volume. It's not filling it up like a bunch of disks. It's just a ring around the outside. So that ring is circumference, which is 2 pi r. So you have this ring, 2 pi r, and then you stack those rings up. Unlike here where we had the area and we stacked the area up, we're just going to stack the circumference rings. So the circumference is 2 pi rh, so the lateral surface area is going to be 2 pi rh, where you multiply that circumference by the height. Again, honors, you are not required to memorize these. So here's the two formulas that you need, volume and surface area. Sometimes we're going to do ones that don't have a top. So maybe you're building, or a bottom, maybe you have a silo that has a flat top and is just sitting on the ground, has no bottom. Then it would only be 1 pi r squared. So there's still going to be a lot of thinking, even if you have the formulas. Okay, what is the purpose of the constraint? To reduce the equation that we're trying to minimize to one variable. So it'd be nice just to get rid of h, then we can have all r's. So I'm going to say h is equal to 36 over r squared. So I use the constraint to rewrite my main equation with only one variable, replacing h with 36 over r squared. This gives me 2 pi r squared plus 72 pi r to the negative 1. These cancel. There's only one r left on bottom. I'm going to bring it to the top because I know that step 4 is to find the derivative. So this area is some kind of graph that I have no idea. So I just always draw the same graph. Whatever this graph is, at some point you're going to have a maximum and a minimum. And I'm trying to minimize the total surface area, not actually negative. So I'm going to minimize the total surface area. And when this graph has a minimum, the derivative is going to be equal to 0. So let's take this derivative, 4 pi r minus 72 pi r to the negative 2. And step 5, set it equal to 0. 4 pi r minus 72 pi over r squared. Clear the fractions. That gives me 0 is equal to 4 pi r cubed minus 72 pi. Bring over the 72 pi. Divide both sides by pi. Divide both sides by 4. What is that, 13? Does that sound right? 72 divided by 4, not 13, 18. Is r cubed, and so r is equal to the cube root of 18. So be careful here that when you put this into your calculator, you can do that, 18 to the 1/3, that's fine. You will get r is equal to 2.621, and our unit is inches. Volume is cubic inches, Surface area is square inches, but just radius is just that. But when you go to find h, you must use the cube root of 18, not 2.621. Okay? Your answers all have to be accurate to the nearest thousandth on the AP exam, and including, if they asked for it, the surface area. So if this number was a little off and then this number had already been rounded, your final rounded answer would definitely be incorrect to the nearest thousandth. So make sure that you do that. And when you plug that in, 36 over the cube root of 18, what I would do is just hit store. Once you get this answer, before you round it, hit store as x, and then just do 36 over x squared, and that'll give you h, which is 5.241 inches. Find the radius and the height. They didn't ask for, so remember, step 6 is to actually find the answers, and step 7 is to find the unit. All right, that was your first day. So now you can do numbers 5 and 9 if you're in AP. In honors, I'll tell you exactly which ones I want you to do. We'll just do one of each kind for homework, not all of them. All right, see you for part 2 on another day.